Okay folks, today we're going to go back to some basics. We're going to talk a little bit about some basics of soldering irons, tinning your iron, soldering iron care. We're going to bash on soldering iron elitists and a few other tips. We'll also learn another hair care tip, and we'll drink some beer. Okay, I'm gonna turn this off here. All right. That is warm. Okay. I should have checked that before. I should have turned this off a while ago. If you have a soldering iron that looks something like this, okay? You unscrew the base down here, you take off that part, and then you take the tip off, and then there's that white ceramic heating element in there. You're going to have soldering iron elitists or soldering iron Nazis telling you that this isn't a good soldering iron. Well, that's a bunch of baloney. Okay, they're perfectly fine. They don't cost anywhere near as much as the other soldering irons that have the heating element in the actual tip, and you can change tips immediately, like you just saw there, me trying to change the tip. I didn't realize my soldering iron was on and I burnt myself. Okay. That really is the only advantage. They'll tell you that another advantage is, well, since the soldering iron is in the tip, or the heating element's in the tip, and it has a sense wire going back to the soldering iron, or to the power, that it's adjusting for temperature, so it doesn't, so it will keep up with the loss of heat from your soldering iron to your soldering plane, your ground plane. Well, it is true, it does do that, but how useful actually is it in micro soldering? Not much at all. Really, honestly, not much. Yes, someday I would like to own a Hacko 5000 or a Weller Deluxe at some point. That's just for vanity. Honestly, these soldering irons with the ceramic heating cores, well, they're easy to fix. In fact, this one right here came with a replacement filler. And even the air one. Now, I do intend to get a rework station where the air is actually, the heat for the air gun is actually produced from the station rather than from your hand. Those are better, okay? They just are better because for several reasons. They're higher quality. This one down here went out already. This one came with a replacement element, so they expect it to go out. So that's pretty much it. Otherwise, if you've got this soldering iron, whether it plugs straight into the wall or it plugs into a soldering station like either one of them that I have here, you're fine. All right. Now, your soldering iron and soldering iron tip tinning Nazis are going to tell you that you have to treat this like it's some piece of equipment on the space shuttle. It's not, okay? I've seen some people that they re-tin their iron after every single time that they solder something on the board before they put it back in the holder. That is overkill, and that is unnecessary. The only thing that you have to really be careful with is you don't want it to rust, because rust causes pitting, and pitting is what destroys your iron. This tip is made of steel. Let's look at it down here, okay? This pit or this tip is made of steel, okay? And so steel does rust, but they're going to tell you not to do certain things to it because it will ruin it. And they'll tell you about, well, how many soldering iron tips that they've gone through, and that's just a bunch of malarkey, okay? Let's go to my microscope again. If your soldering iron will hold solder. Whoops, this one, because I turned it off. Okay, I need to turn it back on. Okay, because I wanted to take off the tip and show you the ceramic, the white ceramic heating element. So I turned it off. Come on, let's get back up. And I run everything at about 405 degrees Celsius. Whenever I'm talking temperature here, I'm talking Celsius. I'm not in the United States. I'm abroad, and so we use Celsius. Come on, get up there. Well, while we're waiting. All right, we're at 405. If your soldering iron tip will do just this, if it will, you see that? It's holding solder, and I can put it even up higher on it, and it melts, okay? That's all it needs to be able to do. And now I'm going to crunch it into this brass thing here. I've got a holder. See if I can get it without knocking anything down here. I do like these holders. They look like this, and it's got this brass coiled mesh that looks like you use it for washing pots and pans. And if you'll look inside, it has some rosin in it. Now that rosin actually does go out pretty quick. The tip I'm about to give you is, I just scrubbed it in there just a couple times, all right? And you don't have to do that every single time you solder something. Oh, I just soldered this capacitor. I need to scrub, re-tin it. You don't have to do that. Look at my tip, okay? It's silver, all right? It's not perfect, but it's silver. And then I want you guys to notice something with doggone it. When I stick this in and go down far enough, you should hear, and maybe even see, smoke. It ran into that rosin, okay? And that's pretty good. And they sell these in lots of different places. In fact, I've got two of them. I've got one right there, and I've got one right here. Much smaller one. And you take that out, and you can see that the rosin in that one actually got used up pretty quick. Well, guys, you know, if you don't have one of these, it's okay, okay? You're going to be able to clean your tip just fine. And in fact, I think better than using the brass mesh with the rosin. And I'm going to use this metal lid, and I'm going to show you exactly what I'm going to do. Okay, we're going under the microscope again. This is a poor man's tip cleaner, and I personally think it is even better. So you take your solder and just start letting it melt. Get in there, get more solder, more and more and more. Let it build up. Put a good amount in there. Put a fairly large amount in there. Okay, and I'm going to put some more in there in just a second. Got to straighten it out. Now you can notice I'm not using flux. There's a little bit of flux in this solder, but not quite enough. Here we go. Not quite enough to keep it from oxidizing. So that's where we're getting some discoloration there on the top part of the solder. Okay? All right. So, I've got that. I've got a blob of solder. A blob of solder is cheap. I just made it real quick. Then I'm going to add flux to it. Okay? Just keep that flux around it. Actually, I've got 2 blobs of solder. And then what I'm about to do requires a little bit of something that I haven't introduced yet, and your soldering iron elitists are not going to like this, and that is steel wool. Oh, but rubbing steel wool on your soldering iron is going to wear it away. No, it's not. Okay, you would have to run, well, I don't know if I would be able to rub that soldering iron away to where it's ruined, you know, within a year. I don't know, maybe I could do it quicker than that. But you're actually not rubbing, steel against steel. You're rubbing steel against solder. Take a look at my soldering iron, okay? Let's get some flux in there. All right. Get more flux. Get my solder on there. Okay. Got my iron into the combination of flux, okay, and solder. Then I'm going to take this and I'm just going to do right like that. Now, check out my tip. My tip is even cleaner, okay? And you do not have to do that all the time. You don't have to run out and buy your brass mess. The reason they use brass is because brass is softer. Brass is softer than steel, but I'm not rubbing it against steel. I'm rubbing it against solder. All right, so you do that a couple times. Come on over here, solder. Here we go. We'll get a little solder on there. Get a little solder. And it's good if your soldering iron does this. See what it's doing? It's dragging solder. All right, that's what you want it to do. And now, here I've got a nice coat of solder on my tip. And then that's how I would put it away. Get you a nice coat of solder with flux on it. Gosh, that's hot. With flux on it, and put it away. Okay? Because actually, most of the damage from a soldering iron is going to take place overnight if you don't protect it. You've got humidity. You've got people messing around. Something could be spilled on your soldering iron. Okay? Now, yes, leaving your soldering iron on all night long at 400 degrees Celsius is going to cause it damage. Heat does cause it damage. That's why you've got a sleep mode and an off mode on it, a 10-minute mode. Heat does help metal oxidize quicker. All right, and then that oxidation gets cleaned off with flux, and then you're basically wearing away your soldering iron. But once again, guys, if this is what you have, it's perfectly fine. Do not let solder iron Nazis get you down. Another thing, along with that, I mentioned oxidation. Most of us go through our lives without ever having really touched actual bare metal. I know that sounds like a weird statement. I'm holding an aluminum can, I'm drinking right out of the top. And no, they didn't put any kind of special coating on there. Metal, most metals other than gold and your higher end metals are non-reactive. That's why they put platinum in catalytic converters and gold plated wiring and components in high dollar electronics. Most other metals oxidize almost immediately, including aluminum. In fact, aluminum oxide is used in a lot of, that's basically aluminum rust, is used in a lot of compounds. You can make thermite with aluminum oxide. Now, let's take a look at this motherboard. Sometimes when you're trying to solder, you can't, like let's say this coil, you want to inject a voltage and you're one of those people that go ahead and solder, you want to solder your, you wouldn't solder your negative, but your positive lead right here, okay? Or you want to solder something right there and it just won't stick. Okay, well that's because there is a layer of oxide on the outside of it, and that's actually good. It protects your equipment, it protects things. Now another thing that you can do with your steel wool is you can go ahead and brush it up and scratch it up and scratch off that outer layer of oxide, okay? And or you can even just use a let's see what we got here. What do I have over here? I've dropped so many things. You know, you can put a few scratches in it, you know, with a tool, all right? And what you're doing is you're exposing bare metal. And then your your solder will stick to it better. Now, soldering is not welding. Metals just happen to, when and your solder is bare metal when it's on your soldering tip and has flux with it. You're putting bare metal to bare metal, and we call that wetting. There are tiny little crevices and cracks and things in metal that at high temperatures other metals can find their way up into there. So they're kind of locking into place. They're not welding, okay? It's actually called wetting. If you want to study that, look that up. Okay, so that's another good use for inexpensive steel wool. You can find this under your sink. You don't have to go out and buy special stuff. And guys, I expect this soldering iron is probably going to last me, I don't know, 10 years, given if the tip or the thermal, oh, what the heck? What produces the heat doesn't go out. I'll just fix that. The odd thing about it is most soldering irons need a soldering iron to fix a soldering iron. Okay. This one, however, you just have replacement ceramic thermal conductors. Okay, another tip that I want to give you guys, don't be discouraged. You guys watch all these people on YouTube and they go immediately to a shorted cap. and you know how to find a shorted cap. You've watched these videos. It's easy. Well, inject voltage, see what's getting hot, whether it be with thermal camera, your finger, alcohol, whatever. You found the shorted cap. Remove it, and if it's not a bypass capacitor, then replace it, okay? From like another board, if you know the value of it, or you've gone out and you've bought, you know, your set of capacitors and resistors and such, replace it. I've been doing this for 8 months now, and I have yet to run into any motherboard where the problem was found a short on the main power rail and it was just a shorted cap. Not yet. And look at my stuff I have. I've got stuff over here, all these boards, computers down here. I've got a box of computers over here. Not one of them have just been a shorted cap. They're more complicated. They wind up being a shorted IC or shorted CPU or GPU, okay? If you go several, like this board that I've been showing you today, this board was in bad shape. This was a student's board. And you know how there's some folks that you just can't find out what's wrong with it. I couldn't find anything that was right with this board. But the problem was not just a shorted cap. It had a short on the 3.3 rail, and it also had a short on the main power rail, and I tracked it down to the actual CPU. So I didn't fix it because it isn't worth that kind of money. The CPU would cost more than they paid for that remanufactured laptop. All right, now I want to get back to some more basics. I don't want to assume anything of my audience, what few of you there are right now. Please subscribe if you're watching this. Let's talk about electricity. I've been using my multimeter, and I've been talking voltage and amps and things like that, and I got to thinking, you know, there might be some people watching that honestly don't know the difference between voltage and amps, or when I say current. There is a huge difference between voltage and amps. Now, if you are a person that don't know the difference between voltage and amps, and you went to a public school, I want you to pause this video. I want you to go out into the living room, confess to your family, and call up your friends that the public school system has failed you. That's just a joke, okay? You may have learned it in physics and it went in one ear, out the other. Voltage is difference of potential. You guys all know that we're talking about the flow of electrons, right? Electrons are charged negative. So I'm going to turn and face the camera a little bit. Okay, let's say over here on this side, you've got a whole bunch of electrons, and over here you just have, okay, let's say you just have a few, okay? Difference of potential means, or voltage means, that there's a difference between the number of electrons here and the number of electrons here. That's all that means. Now, to give you an idea of that difference of potential that you see in everyday life, lightning. Clouds get to rubbing together, and they eventually build up so many electrons from that rubbing together. They wind up building up so many electrons in that cloud, and they want to go somewhere, but they will not go anywhere until there is so much of a difference of potential that it will either travel through the air from cloud to cloud or cloud to ground. And it has to overcome that resistance of the air, because air is not a good conductor. So the voltage level of lightning is like 30,000, 40,000, 50,000, sometimes 100,000, 200,000 volts. Okay? Air is not a good conductor. When you scoot your feet across the floor and you touch a doorknob or something and you get that shock, that little pop, and it just gives you a little sting, that's about 5,000 volts. And you have that kind of voltage running through you all the time if you're walking on carpet. All right? Amps, on the other hand, are actual amount of electrons crossing a certain point per second. I think it's called a coulomb. One coulomb it equals so many electrons, and it's a number that that's huge. An actual amp is very large, number-wise, very tiny. You know, you can't see an amp because an amp is actually an amount over time. Okay, so let's say that this can right here is 1/1000th of an amp. Okay, and I throw it at my hardest, and let's say, and actually remember, electricity, amps aren't pushed, they're pulled. So let's say it's pulled out of my hand at 110, or if you're not in the United States, 220, 240 volts. That's as hard as I could throw it. It did nothing, okay? Because it was only a couple thousandths of an amp. Well, let's say that this bottle is a quarter of an amp, all right? And I were to throw it as hard as I could, it'd break my window, all right? Voltage doesn't kill you, and voltage doesn't make things hot. Amps do. And so that's why we look for heat when we're looking for a short, because amps, the current, is taking the path of the least resistance. Current flows exactly, not kind of like, exactly like water, regardless of the voltage behind it or that it's being pulled by. If you've got 50 amps up in the sky, and you know, or let's say 50 amps up in the sky, and there's 200,000 volts, and that can overcome the resistance of the air. Okay, and the resistance of the air is the reason why you see that, is because those amps actually heat up the air so hot, so fast, so quickly, hotter than the surface of the sun, that it blasts the air away from it, and that's what makes thunder. But if you were to run a wire, regardless of what that wire was, even a wooden pole up to there, we'll take the wooden pole and take, I don't know, you can get it down through a wooden pole with, you know, I don't know, 30 volts. It'll take the path of least resistance. Okay? I hope you understand that. All right. Well, guys, we've drank some beer. We've bashed on soldering iron Nazis. We've learned a few tips, and we've drank some beer. What I'm using right now is the stuff that you use to fry stuff in, like taters. And it does not get as rancid as butter. It's cheaper than olive oil, and most households have it. And no, it doesn't smell good. Well, that's what you wear cologne for. Okay? Guys, thanks for joining me again. Please subscribe, tell your friends, and have a happy new year.